Right, a passing examination paper question. So this is from Edexcel. It's a core mathematics question from C3, June 2008, and this is question number 6 of that paper. So part part 1 of A. Differentiate with respect to x, and we needed to differentiate e to the 3x into sine x plus 2 cos x. So let me attempt A part 1 here. So A part 1. So we need to differentiate, and let me copy that down, the function e to the 3x into sine x plus 2 cos x. Now, as you can see, we have a product of two functions, both in terms of x, so we need to use the product rule in this case. So let me take my red pen. I'm going to take my u to be e to the 3x when it comes to the product rule, and I'm going to take v to be this entire term within the brackets. So my v is going to be sine x plus 2 cos x. So let me select my favorite color, blue. Let me first write down the product rule. So by product rule, so d by dx of uv. So whenever you differentiate a product of functions u and v, both of functions of x, so the rule is v du over dx plus u dv over dx. Now let me do some side calculations. So I've chosen u to be e to the 3x. And let's calculate du over dx. So let me scroll a little below. So du over dx. So when I differentiate e to the x, I'm going to get e to the x multiplied by the derivative of 3x. So this arises from the chain rule of differentiation. Now, if you're unfamiliar with the chain rule of differentiation, especially when it comes to exponential functions, I have created videos on the channel, and I'll provide links to those videos in the description below. However, let's continue over here. When I differentiate 3x, the answer of which is 3, and 3 into e to the 3x, let me leave it as 3e to the 3x. So that is the derivative of u. However, we need to differentiate v. So let me do another side calculation. So let me scroll down below. So v in this case, let me remind myself, that was sine x plus 2 cos x. So let me copy down the sine x plus 2 cos x. And let's work out dv over dx. So when I differentiate sine, it's cos, so cos x. And when I differentiate cos x, it's a minus sine x, so that when I differentiate 2 cos x, I'll get a minus 2 sine x. So this being the derivative of v. Now let's substitute this into our product rule here. So let's see what we're going to get as a result. So d by dx of u, so u is e to the 3x, into our v, so v in this case is sine x plus 2 cos x. So let's copy that down, sine x, whoops, let me make it as neat as possible. So sine x plus 2 cos x. So that being v, so v is sine x plus 2 cos x. So let's copy that down carefully. So sine x plus 2 cos x multiplied by du over dx, and du over dx is 3e to the 3x. So 3e to the 3x plus, according to the rule, so plus, and u is e to the 3x, so e to the power 3x multiplied by dv over dx, and dv over dx in this case is cos x minus 2 sin x. So let me copy that down here. So cos x minus 2 sin x. Now let me scroll a little below and let me continue over here. So that means that d by dx of e to the 3x into sin x plus 2 cos x. So that is equal to, so when I multiply these two terms, 3e to the 3x times sin x, so that is 3e to the 3x sin x, 3e to the 3x times 2 cos x, so that being a 6e to the 3x cos x, e to the 3x times cos x, so that's a plus e to the 3x cos x, and e to the 3x times minus 2 sin x, so that being a minus 2 e to the 3x sin x. So this is what we get as a result of multiplying out the brackets here in the previous step. And let's go one stage further and simplify this. Let's add the like terms. So I have a 3e to the 3x sin x from here, minus a 2e to the 3x sin x from here. So 3 minus the 2 is a 1 e to the 3x sin x. So I have a 6e to the 3x cos x plus a e to the 3x cos x. So when added, that gives us a 7 e to the 3x cos x. And if I go one stage further, so let me scroll down, if I take a common factor of e to the 3x, we're going to be left with sin x plus 7 cos x. So this being the solution to the first part of A. Now the second part of A, let's have a look at this one. So we need to differentiate with respect to x, x cubed ln 5x plus 2. So let's have a go at this one. So let me continue below. So part 2. So we need to differentiate x cubed ln 5x plus 2. So in order to differentiate this term, so again we've got a product of two functions of x. We have an x cubed and an ln 5x plus 2. So the ln 5x plus 2 is one function in terms of x, and the x cubed is also a function in terms of x. This is a product of two functions in terms of x, so we need to use the product rule again. So if I take my red pen, I'm going to take my u to be x cubed and my v to be ln 5x plus 2. So let's apply the product rule one more time. So by product rule, so remember the rule, d by dx of uv, where u and v are functions of x, that is the same as v du over dx plus u dv over dx. So u in this case is x cubed, so let's do a side calculation. U being x cubed, so du over dx, if I differentiate x cubed, that being 3x squared. So let's do a side calculation for dv over dx. So v is ln 5x plus 2, and let's differentiate that using the chain rule. Dv over dx would be 1 over 5x plus 2 multiplied by the derivative of 5x plus 2. So this is a result of applying the chain rule. So once again, if you're unfamiliar in terms of differentiating a natural logarithmic term using the chain rule, I have created videos on my channel and I'll provide links to those videos in the description below. However, let's continue. So when I differentiate 5x plus 2, that being 5, so let's make a note of that. And if I continue my side calculation, dv over dx will be 5 into the 1 is 5, so it's 5 divided by the 5x plus 2 below. So this is what you should have for the derivative of v. Now let's apply these into our product rule. So let's plug into the product rule. So d by dx of u is x cubed, so x cubed, into v is ln 5x plus 2, so ln 5x plus 2. That is equal to v is ln 5x plus 2, so ln 5x plus 2, multiplied by du over dx. Du over dx is 3x squared, so multiplied by 3x squared, plus according to the rule, so plus u is x cubed, so x cubed, multiplied by dv over dx, and dv over dx is 5 over 5x plus 2. Now let's go one stage further. So when I multiplied out the brackets, 3x squared times ln 5x plus 2, so that being 3x squared ln 5x plus 2, plus, so a plus 5 times x cubed, that being 5x cubed, divided by the 5x plus 2 below. So divided by this 5x plus 2, that arises from here. So if I factorize this, if I take out a common factor of x squared, as x squared is common to both terms, by taking out a common factor of x squared, I'm going to have 3 ln 5x plus 2 from the first term, plus, so a plus 5x all over the 5x plus 2 below. So this being the solution to the second part of A. Right, moving to part B. Given that y equals 3x squared plus 6x minus 7 divided by x plus 1 squared, where x is not equal to minus 1, in part B we need to show that dy over dx is equal to 20 over x plus 1 cubed. So let me try part B here. So let me copy down y. Y is 3x squared plus 6x minus 7, all divided by the x plus 1 squared below. And we need to calculate the derivative dy over dx. There's a number of ways of doing this one. You can use the quotient rule, since we have a quotient of two functions in terms of x, or you can bring this denominator term upwards and apply the product rule. Now I'm going to be using a quotient rule here. So u for the quotient rule is the term in the numerator, which reads 3x squared plus 6x minus 7. V being the term in the denominator, which is x plus 1 squared. And let's use our quotient rule. So by quotient rule, so let me write down the rule. So d by dx of u over v, so that being v du over dx minus u dv over dx, all divided by, so it's all divided by v squared. So that is the quotient rule. Now let me do a side calculation. So u is the term in the numerator. So u is 3x squared plus 6x minus 7. And let's work out du over dx. So when I work out the derivative of 3x squared plus 6x minus 7, so that gives us 6x plus 6. So that is du over dx. V is the term in the denominator, which reads x plus 1 squared. And let's calculate dv over dx. Now, to work out dv over dx, or the derivative of such a term, we need to use the chain rule. So if you're unaware of how the chain rule is applied, I have created videos on my channel, and I'll provide links to those videos in the description below. So here's how the chain rule is applied. So in this case, we're going to multiply by the power. So 2 into x plus 1, and subtract 1 from the power. 2 minus 1 is a 1, and we multiply by the derivative of x plus 1. So once again, if you're unfamiliar in terms of how the chain rule is applied, I'll provide a link to the video that I've created in the description below. Now, when I differentiate x plus 1, that being 1, so we're going to have 1 for the derivative of this x plus 1 term here. 1 into 2 is 2, so that would make dv over dx a 2. So the 1 into this 2 is 2 into the x plus 1, which remains. So this should be the derivative of v, which is x plus 1 squared. Now let's apply this into our quotient rule. So let me scroll down slightly. D by dx of u is 3x squared plus 6x minus 7. So 3x squared plus 6x minus 7, all divided by the v is x plus 1 squared, so x plus 1 squared. So that is equal to v is x plus 1 squared, so x plus 1 squared, multiplied by du over dx, which is 6x plus 6. So multiplied by 6x plus 6, minus the u, so minus, and ru is 3x squared plus 6x minus 7, so 3x squared plus 6x minus 7, multiplied by dv over dx, which is 2 into x plus 1, so into 2 into x plus 1, so let me squeeze that here, all divided by v squared. So let me take this line feature, so it's all divided by v squared, and v, if I go back to my blue pen, v is x plus 1 squared, so x plus the 1 squared, but it's a v squared, so we need to square again. So in this case, I've got 6x plus 6. Now 6x plus 6, I can take a common factor of 6 to give me 6 into x plus 1 from here. So if I take my red pen, so I factorize this, giving me the 6 into x plus 1. So as you can see, I got an x plus 1 squared and an x plus 1. So that is going to give us an x plus 1 cubed for the first term, in regards to the first term. But I also have an x plus 1 as part of the second term. So I'm going to take a common factor of x plus 1, okay, as a result. So if I revert to blue, so if I take an x plus 1 common factor, and if I use a square bracket, just to make it more clearer, from the first term, as a result of this common factor, I'll have 6 into x plus 1 squared. So x plus 1 squared into the x plus 1 will give us the x plus 1 cubed from multiplying these two terms. And this 6, I've kept that over here as a result of the common factor. Minus, so a minus, by taking out an x plus 1 as a common factor, we're left with a 2 into 3x squared plus 6x minus 7. So that is the term that remains. All divided by, so it's all divided by the x plus 1. So the x plus 1 and power 2 to the power 2. So a squared to the power 2 is a power 4. So this is what we'll get as a result of taking a common factor of x plus 1. Now, as a result of that, I can cancel this x plus 1 with 1 below to give me an x plus 1 cubed. So that is what we're going to have below as a result of the factorization. But let's go one further step. Let's get rid of the brackets on the top. So we have a 6. X plus 1 squared, when multiplied, will give us an x squared plus 2x plus 1. And I have a minus 2 into 3x squared. That will give us a minus 6x squared. Minus 2 into plus 6x, which is minus 12x. Minus 2 into minus 7, which is a plus 14. And that is all divided by, so all divided by this x plus 1 cubed below. And we can do some further multiplication. So let's do that. 6 into x squared is a 6x squared. 6 into 2x is a 12x. 6 into plus 1 is a plus 6. Minus the 6x squared. Minus this 12x. Plus this 14. Let me scroll down below. So that is all divided by, so let me use this line feature again. So all divided by the x plus 1 cubed below. And as a result of getting rid of these brackets, I can cancel the 6x squared term with the minus 6x squared term, as well as the plus 12x with the minus 12x. So what we're going to have as a result, 6 plus 14, that is 20, and it's 20 divided by the x plus 1 cube term below. So that, I believe, is what we needed to show as part of this particular part B. So that is exactly what we've got over here. Right, moving on to part C. Hence find d2y over dx squared, so the second derivative, and the real values of x for which d2y over dx squared is equal to minus 15 over 4. So let's attempt that problem. So first of all, we need to use our answer for dy over dx to calculate d2y over dx squared. So for d2y over dx squared, we need to differentiate dy over dx one more time. So let me attempt part C over here. So for part C, let me copy down the solution for dy over dx. So for from the previous part, dy over dx, we had 20 divided by x plus 1 cubed. And let's rewrite that as 20 into, if I take the x plus 1 cubed up, so the sign of the power will change. So it will be a minus 3 power, so a negative power. And based on this, let's work out the second derivative. So let's work out d2y over dx squared. Whoops, so let me make it as neat as I can. So in order to work out the second derivative, we need to use the chain rule. So once again, I have created a video in terms of how the chain rule is applied. So a link to that video will be given in the description below. But let's apply the chain rule here. So if I multiply by the power, minus 3 into 20 is minus 60 into the x plus 1. If I subtract 1 from the power, minus 3 minus 1 is minus 4, multiplied by the derivative of x plus 1. And if I go one stage further, when I differentiate x plus 1, we'll get 1. So let me continue below. So d2y over dx squared, that is going to be minus 60 into 1 is minus 60 into the x plus 1 to the power minus 4. So that should be the answer for d2y over dx squared. However, if we go back to the question, so we found d2y over dx squared, but we also needed the real values of x for which d2y over dx squared is equal to minus 15 over 4. So let's move on to that part. So d2y over dx squared, that is equal to minus 15 divided by 4. So let's use our answer from here. So we had minus 60 into x plus 1 to the minus 4, that is equal to minus 15 divided by 4. So first of all, let me divide by minus 60 on both sides to get rid of this minus 60 here. So if I divide both sides by minus 60, we're going to have x plus 1 to the minus 4, that is equal to the minus 15 over 4 divided by the minus 60. Okay, so in this case the minus 15 and the minus 60 will cancel 4 times, and we're going to have as a result 1 over 4 divided by 4. So 1 over 4 divided by 4 is 1 over 16. Now I can also bring this this term down to make this negative power positive. So I'm going to have a 1 over, moving the term down, x plus 1 to the power plus 4, that is equal to 1 over 16. So if I rearrange from here, we're going to have that x plus 1 to the 4 is equal to plus 16. Now from here on, let's take a fourth root on both sides. So x plus 1, by taking a fourth root on both sides, by taking a fourth root, be sure to put a plus and minus. So it's plus and minus the fourth root of 16. And the fourth root of 16 is 2, as 2 times 2 times 2 times 2 gives us 16. So it's plus and minus 2. So if I therefore take the plus 1 to the opposite side, x is going to be minus 1. So plus 1 to the opposite side will make it minus 1 plus or minus 2. So here are the values of x. So if I scroll down, x is going to be minus 1 plus 2. Minus 1 plus 2 is plus 1. So let me just say that either x is equal to plus 1 or x is equal to minus 1 minus 2, that would be minus 3. So here are the two values of x that they're looking for, and these are the two values of x for part C. So not only that completes part C, so we've completed the entire question. So I hope you enjoyed this video. If you did enjoy the video, if you did like the video, be sure to like and subscribe, and I hope to see you again. Thank you.